We are on to our last presentation of the day. As I mentioned earlier, Kristie will be giving our last presentation that's revolved around automating the boring stuff, which some of us still like the boring stuff, and building and monitoring efficient production data science pipelines. Really what this presentation is about, as I mentioned, it'll give an end-to-end overview of doing production data science and machine learning in Domo. Heather just gave a little bit of an insight and example of what Domo has to offer. I can say that I've worked with many tools from Alteryx to Domo to Tableau and many others, and Domo's great. It's fantastic. It gives the ability to really leverage data science, and since we're spending a lot of time talking about machine learning and applied artificial intelligence, we thought that this would be a great presentation to bring you. So without further ado, Kristie, if you are ready, I can hand the mic over to you, and the stage is all yours.
Thank you. All right. As Tom mentioned, I'm going to be talking about building and monitoring efficient production data science pipelines. I work for Domo, so I'm going to be talking about how to do that in Domo. You can do that anywhere, and I will be highlighting technology and technological features that help make this happen a little faster. I am going to be talking about automation, and Tom, some people may actually like the boring stuff, and that's cool. You can always do the boring stuff if you want. But if you don't want to, I've got some automation ideas for you as well. To get started, I wanted to present my key points, my key insights that I want everyone to learn a little bit more about during my presentation. I'm going to do this at the beginning. We'll wrap up with the same kind of information. But first, what you're going to see is I feel like good data science production pipelines start with really good business intelligence. And if you do it well, as we've heard in other presentations today, data science can piggyback on that really good business intelligence and your analytics to inform your data pipeline in a much more efficient manner. All data science production pipelines should include the ability to monitor and refactor models, and a lot of that can happen automatically. And then finally, I think that any good data science solution should be built around the end user experience, and that the end user experience should drive a lot of what we do. So those are the three topics I'll spend a lot of time talking about today. What is Domo? You've heard a little bit about Domo, so I'm going to steal the information right out of our marketing playbook. Domo is a full stack data production platform that delivers BI leverage at cloud scale in record time. If you've used Domo, you'll know a little bit about this. If you haven't, that's okay. I'll walk you through a little bit about it. Domo combines data warehousing with analytics. So the first thing that you'll ever do in Domo is connect and store your data. We have over 4,000 native connectors. We can connect from all different types of data sources. And the more important piece of this is you can connect it and automate the ingestion of your data connections. So we're dealing with live data. And that's one of the important parts of building a production data science pipeline, is making sure that your data are live and that you can take action in near real time. We can then clean and join transform data with our ETL layer. That feeds into our visualization layer, where you can do just about anything you want to, especially with the apps platform that is inherent in Domo. And we didn't stop there. We created opportunities to collaborate around data, to build meetings around data, to set alerts and have Domo monitor your data for you so that you're not watching it every day. And you can do what you do best, and you can do your job without really worrying about what's going on unless you're getting an alert. That also allows you to set interventions and monitor them. I'm super excited about announcing that the newest member of the Domo family really is data science and AI. So we've incorporated some AI leverage into our platform as well. And probably the most exciting piece about this is that our data science dev and production environments sit right in between our ETL layer and our visualization tools. And because of that, you can do really cool stuff in terms of building automated data science pipelines that might be a little more difficult to do in a different platform. And so we've got lots of different options there for you. Jupyter workspaces are what we use for dev environments. You can code in either R or Python in those environments. The production layer is R and Python scripting, and we also have some low and no code options, including AutoML, in our integration with SageMaker Autopilot. So now we get to the question, okay, we're talking about production data science. What is it? If you go out there and do a Google search on production data science, you'll come up with a lot of different definitions. And a lot of people talk about it differently and think about it differently. So I'm going to tell you how I think about it. Doesn't mean you have to think about it this way, but we can all be on the same page for the presentation. So first thing, I think production data science should be modular. It needs to happen in a pipeline framework, which facilitates unit-tested code base and continuous integration. Production data science, just like all data science, should be reproducible. It is science after all. We have to be able to reproduce our results. That includes version control, environmental consistency across your dev and prod environments. And by the time you move to production, that code should be lean, efficient, and well documented. So data scientists who didn't necessarily work on the project should be able to understand all of the decisions made during that production model development and deployment. Lastly, it's got to be automated. Should be scalable. We should be able to monitor the results for model drift and model rot. And lastly, we need to be able to visualize actionable results that end users can actually look at and understand, and it's intuitive for them to take action on. So why don't we see more production data science? It sounds great. It sounds awesome. Shouldn't we all be striving for this? Yes, but an estimated 1 in 10 data science business initiatives actually result in a production workflow. So why? I think that's a really good question to ask. In my years as working as a data scientist and in managing a consulting organization that does data science for customers, the biggest answer I can give you is there are so many reasons why we don't move a lot of data science models into production. And I think most of those can be encompassed by the simple fact that it's really challenging. Like, this is hard. And there are challenges at every corner. So this is really difficult to do. One of the reasons it's challenging is because data science is inherently greedy. So rarely in my career have I ever met a data scientist who said, oh yes, I have enough compute resources. I can estimate as many models as fast as I want. I have enough data. My data is the highest quality I could possibly get, and my models are amazing. I never really hear data scientists say that. Rather, data science is iterative. And because of that, it's never really done. It's due, there are deadlines for it, but it's never really done. And if you move it into production, there has to be a cycle for iteration. And if there isn't, then it feels kind of final for a data scientist. And it's hard to deploy something that requires more iteration. There are often organizational constraints as well. There are reasons why businesses may not buy into data science models or may find them difficult to use. And lastly, there are technological constraints. So this one, I don't think there's any excuse for. We have really good technology today. And if you have technological constraints, what happens is your data scientists end up doing tasks and projects that are not taking full advantage of their skill set. And if you're paying a data scientist to do something that could be automated in technology, you're paying way too much for that task to be done. Data scientists are very, very expensive. So we want to try to automate everything that we possibly can, unless, of course, Tom wants to do it. We'll let him do what he wants. And use the data scientists to do our more complicated thinking tasks. If you go out and if you're used to looking at workflows, data science workflows in particular, you'll probably find something like this. This is nothing special. This is kind of a standard workflow. Some workflows might include a few more boxes, a few more features. Some might be linear instead of circular, but they're all basically the same. One thing you'll notice about this is there's no mention of production data science at all, which is typical. That's common. Production data science seems to be almost an afterthought when you're talking about your data science workflows. If you find a model that includes production data science, usually it's just another box. So you've got it here over on the left that productionize the model just as another thing. It's just another checkbox that you can do. And for if you have the right technology, your production data science can be so much more than just another box that you could do or don't have to do along the way. So I'm going to present a new model for you today. And of course, this is something that I'm going to put out there, and it's science, so we can talk about it and iterate on it and make it better over time. But this is something that governs our practice at Domo in our data science consulting world. The first step is business intelligence workflows have to be acknowledged and understood. And usually your business intelligence groups are the ones who often have access to data or understand the KPIs and how the business wants to see them measured. They're often getting the definition of the problem right from executives, and then they're iterating on those sorts of things. Data science doesn't always happen together with business intelligence because data science looks at things different and we think about data different. But there is a workflow for that as well. Just because they happen in separate workflows doesn't mean they shouldn't inform each other, and they should. And if you have the right technological platform, they can, because all of your data are in the same place. You can combine it. You can easily put it together. You can easily take it apart. If data scientists want to put control data in there, they can. That control data can feed back to what the business intelligence group is doing and inform better data decisions, inform business best practices. And then we also know that because the data scientists are working from the types of data that the business is used to seeing, and they're working closely with business intelligence folks to do that, they're not over-rotating on forcing the data to fit a model. They're actually thinking about how the data need to be interpreted by the business to make business decisions on. Data scientists are famous for taking KPIs and changing them up a little bit so that they work out better in their data science models. But then that gives the business users and the end users two sets of measures to try to manage, and they don't always work nicely together. And we need to make sure that we're doing work, and data science especially, that is very easy to interpret for your end user. So if we put everything in one place, then we can manage this quite a bit better than we might be able to otherwise. So with that, I'm going to jump into my live demo. Please note that the live demo is going to be demo data. So this is not real data that I'm sharing with you. We take privacy very seriously. So I'm going to demo in a demo environment. The first step, if you follow my production data science ideas, the first step is to make sure that we're getting our data that's already curated from our analytics team. And if we do that, we all know that data cleanliness for analytics is very different than data cleanliness for data science. But that doesn't mean that we can't be working from the same data sources and data sets and be working together on those. So the first thing that we do is find a nice curated data set from our analytics team, and we track it. And we build all of these metrics around every single column in those data sets that we think are going to be useful for our data science models. We build in metrics that matter, mins, maxes, means, counts, et cetera, so that we can track things like nulls. We can track things like data schemas. In data science, we have to anticipate a certain schema so that our model is going to run appropriately in many instances. And so we put alerts around this. And it's as simple as that. If we see inconsistencies with what our analytics team is building, then we work those out and navigate those before we move farther in our production pipeline. But we're dealing with live data in this sense. So as your data update, these could change. Your mins and your maxes could change. And if that is something that could throw off your model, you can set an alert on it, and Domo can help you know when you can go back and look at that. And you're not having to monitor your data every single day when it updates. We can do correlation matrices and other descriptive statistics that are filterable and easy to consume. We also, because Domo allows you to write your own scripts, we have written scripts that will do basically any kind of data profile you want in a matter of minutes. So instead of building all of these visualizations, you just run a script and it will do it for you. And they'll update live, and you can highlight things like nulls. So if you're concerned with nulls, you can get alerts every time data come in that have nulls in it, et cetera. We can do box plots. We can do scatter plots. And instead of building these for every single column in your data set individually, you can do it programmatically. And then they will update live and you've got it. And you can always go back and monitor it if you want to, or you can just wait for Domo to send you an alert if you need to go take a look at it. So that's our profiling. That's the first thing that Domo's really great at automating. The second thing is tracking your models. So this is a typical model dashboard that we might use. And the first thing that we'll do is set a baseline. And this is really important for the business to know where you've come from. It's really easy to criticize a data science model if you don't know that it's an improvement over what you were doing. And that's what we emphasize in our practice. In this particular example, the business was estimating employee turnover. So they were creating estimates for when they thought employees would turn over, and they were right about 1/3 of the time. So a good model is one that gets us closer to 100% of the time, but it doesn't have to be 100%. That's not the definition of a good model. A good model is something that gets us better than 33%. So we built a model, and our validation set indicated that we were 72% accurate, which we thought was pretty good. And if we want to iterate on this in the future, we can build yet another visualization and another visualization so that we know the history of this use case and how far we've come over time as we're investigating and working on improving the models over time. The other thing that we can do in Domo, again, because it's an automated system and a really nice production environment for automation, is anytime you want to retrain your model, you can track it. And you can take a look at what happens to the model as you retrain. You can put whatever fit statistics in here you want, whatever accuracy measures you want to put in or error measures, and track them over time. And if your model is getting better and better every time you train, then great. If it's getting worse and worse, then at some point you might want to set an alert on it so that you know. And you can even set a kill switch. If it goes below a certain level, you can kill all of your visualizations downstream so that nobody is taking action on data or models that you think might be problematic. So those are important features to consider too. Because Domo has a lot of different visualization options, you can put in your data dictionaries. So this could be rolled out to a technical user, or you could put enough information on there that your businesses could become, and your business users can start becoming used to looking at this kind of data and these kinds of models. Now, my personal favorite, because I haven't found an easier format to do this in, is the prediction monitor. So envision a situation where you have current employees at your business. You're estimating when they're going to turn over, or how many months they'll be employed at the company. So within that, you'll get an estimate for each employee with an upper and a lower bound of an interval to tell when your estimate is accurate versus not. And once those employees start turning over, you'll know if your estimates were right or wrong, and by how much they were right or wrong. So you can see here that we've got a couple of overestimated cases, a couple of underestimated cases, but 68% of them are correct. And that's really close to our validation set that we were already looking at. In my view, you can't really do machine learning without this. One of the fundamental tenets of machine learning is that you're giving the model feedback on accuracy. And the only way you can really do that is if you're tracking how good your model is and how accurate it is on making its predictions, and then taking a look at these to tell why you're overestimating or underestimating, or if you can see anything in common that would improve your model over time. I have talked to a number of businesses, and I've asked them if they're predicting or monitoring their predictions over time. And they all tell me, oh, we know we need to do it. We really want to do it. But it would take so much time for us to go back and monitor our predictions historically and see where we've been right and where we've been wrong to feed those back into a machine learning model. And it would take months. And that's months that you want to allocate your data scientists to doing data science, not this particular thing. So let's automate it. Let's get a technology platform that will do it for you. If you set it up like this at the beginning, super, super easy to monitor. And you have so much better information about what you can do to improve your models and refactor them over time. All right, with that, I also have an end user dashboard. And in the interest of time, I'm going to go over this very quickly. If anybody has questions, I'm happy to answer them. For the interest of the demo, I've put a lot of different information on this one dashboard, but you could envision different dashboards for different purposes. So if we're talking about employee turnover, an intervention might be at the business level. Where do you put your recruiters? And where do you start having them work? Or where do you start thinking about business level interventions? And this visualization right here is probably going to be very useful for you because we're looking at different branches of the business and seeing what kind of needs are likely to exist in the future. On the other hand, this visualization right here will be much more useful for a manager where we've listed out the names of the employees, when they're likely to turn over, and you can drill in and look at the local feature importance that determined the prediction for this particular employee. So we can see that Sabrina here is very, very low relative to the average employee on completed professional development and very low in terms of her months in her current job profile. She's also really, really high on management succession. So these are going to be things that most likely contributed to the model estimating her turnover date. And something that an employee or a manager could talk about to Sabrina if they were having conversations about how she's doing in the company and what her goals are and what her plans are for the future. We can also include things like global feature importance. So for the entire model and this entire population, what seem to be the big drivers, and we can see that. And because it's demo and because we also have a really flexible app platform, we can do what if analysis pretty easily with a very simple app. We can select various things that we might think would matter in terms of employee coming to the company and staying there for longer versus staying there for a less amount of time. And then we can play with these sliders and figure out if we improve things or if we increase things, what happens to the number of months an employee will stay. And for last bonus, not much. But if we take a look at equity grants, that has quite a big effect. So you can get something in the hands of a business user where you don't have to be a data scientist to understand it, but you can understand how things work together in your data from taking a look at that. All right. I am going to head back to my PowerPoint here. And just to wrap up, again, the key insights that I have here, start with good business intelligence. If BI is the foundation of what we do in data science, we can set up a really efficient pipeline that keeps all aspects of the business talking to each other about data. And if we want to make good data-based decision-making, that's exactly the way that we need to go about doing it. Secondarily, it's not production data science if we can't monitor and refactor those models, and if we're not learning how to improve the models over time. So that needs to be a core feature of production data science pipelines, and with the right technology, it's really easy to do. Lastly, build solutions around the end user experience. Think about what they need and how they need to execute on it and how they need to take action on it. Even the best and most efficient data science is not useful at all if business leaders can't easily understand it and take the appropriate action on the results. And with that, thank you so much for attending today. I really appreciate the opportunity to talk with you today, and I'm going to give it back to Tom for questions.
Wow, thank you so much, Kristie. That was fantastic, and I think it's wonderful. You've changed my opinion. I don't want to do the hard stuff anymore. So, no, I think it's wonderful how it's all integrated there within Domo, within the platform itself. It just seems to make the life of a data scientist so much easier where they can actually spend time on the science part rather than just what am I doing with my data part, which is something that we know, as you mentioned, very important, particularly given the skill set of those individuals. So we do actually have quite a few questions if you don't mind sticking around and answering some.
Great.
All right. So we have this one from an individual. It says, how often do you suggest that production data science models are refactored or retrained?
That is an awesome question, and I'm going to give the answer that I always hate getting, but I always give it. So there we go. It depends. It really depends. If we're taking action on our data science models in really meaningful and important ways, it's going to shift the way our data look in the future. And data science models are only good if what has happened in the past is a good representation of what's happening now or what's happening in the future. So if we're changing the landscape, we have to go back and change our model. And so when it stops fitting as well as you need it to, or if you've taken a really big intervention that you know works and you want to go account for that in your models, those are all really, really good times to refactor.
Nice. No, that's good advice. Here's one that says, a question for you. How are data profiles automated in Domo? And is there a type of automation behind paid walls?
Good question. That's an awesome question. I'm working really hard to get data profiles integrated into the platform, and I'm making progress. So we have a basic version of data profiling in the platform right now. Is through the data view. If you're familiar with Domo, and that is also always being improved, and we're in the process right now of doing feedback on a new version of that, and it will come out soon and you'll be able to see it. One of the things that I love about that is it gives you an overview of what your data set is. The thing that I like about running a script, which is what I've done, my team has built custom scripts, and if you work with us, you get custom scripts. That's just as easy as it is. We're also going to put those in the App Store very soon. So you'll be able to automate all of this and use the code base to tweak it however you want to do the kinds of visualizations that you want to see. So with that, the reason that you would run a script is because you get the physical visualizations, the physical cards, and those are alertable. And that's the best way to set alerts on your data schema.
Nice. Well, great. Yeah. I think this one's actually pivots and maybe takes a few steps back, which I've actually heard this a few times, and I'm sure you have an opinion on this, Kristie, which is if a business is new to data science, what would you recommend, or how would you recommend them getting started?
This is such a great question. Every business that's going to be in business for the foreseeable future needs to use data, like absolutely. But you start your data journey with data. Like start by taking a really good look at your data, see what you have, see what you don't have, see if you can get the things that you think would be useful to have, and start with your data and start building your BI and your analytics, a really strong BI and analytics team around that. Start with good KPIs. Like just start with the really simple stuff. Get started with what you have. That's what I always say. Like you're going to be doing data science eventually. You've got people who are going to be in business have to use data, and they have to use it really well. So start with what you have and expand from there.
Fantastic. Yeah, it's almost if you're just thinking about it, you're already ready. Just go.
If you're asking questions about it, dive in and start with what you've got. I think that's great. I love it, Tom.
So this might be a little more detailed. It sounds like somebody may be familiar with Domo here. It says, can I define all pipeline components as code, in quote, maintained in source control and tested and deployed automatically when changed?
Yes, you can. The automation piece of that, I think, is currently under development. So keep looking out for that. But you can do it, and we're creating new ways to do this all the time. And my team's constantly developing best practices around that. We're kind of on the forefront of figuring that out for Domo users. So again, if you have more detailed questions, feel free to email me. I'm happy to talk to you.
That sounds like you're working on not just having the first easy button to make this automated, but a second easy button there. So it's continuously doing it, which would, wow, that's amazing. Couple more here. It seems like everyone is doing data science these days. What would you say is the most important business or things businesses can do to gain an advantage through data science? So a little bit different than two questions ago.
Yeah, and I've heard a lot that, everybody's doing data science, but I don't want to do it the same way that everybody else is. We have to be new and innovative in order to really make this happen. And, I think that's a really good question, and it's a really good thing to think about. The number one thing that I would say is you're going to differentiate your data use by the data that you have. if you can get better data, your data science is going to be infinitely better, and it's going to inform the actions that you can take infinitely better as well. So get better data. I loved the ready signal discussion today. Control data is a really good way to start improving your models. Take a look at the data that you've got and see if there's any reasonable ways to improve it. If you can't think of any, start working with the data scientists. They will tell you, they will have a million ideas on how to improve your data. And then I think the last piece of that is simply understand that data science it's not the answer to all of your questions, right? It's not going to give you a business advantage by itself. It's what you do with it. So use it better. Like, think about, be more innovative, be more creative about what you can do with the things you're learning from your data science. And that's going to give businesses a huge competitive advantage in the future.
Great. Another question here, which actually goes to sort of follow up with you were talking about understanding and improving the models. Many data science models are ultimately not moved to production because the business may be concerned that they're not accurate enough. What benchmarks do you use to know when a model is good enough for production?
I hear this one all the time. Like, how do we know it's ready? And data scientists, they're a funny bunch. Like, sometimes we like to sit in the corner and be like, I'm not going to show it to anybody until it's perfect. And that's just not the way businesses run. And so my benchmark is, if you are getting results from your data science models that are better than what the business is already taking action on, it's ready to move it into production. You can always come back and revisit, but it's ready. If you're better than what the business is already doing, it is ready. The caveat to that is it has to be a really good end user experience. So if you just throw a dashboard out there and expect the business to take action on things and they don't know what's going in behind the scenes in the model, they don't know what kinds of things might be happening that would inform, a negative prediction or a positive prediction or whatever, then it's going to be really hard to use. And the end users are not going to be very patient with things like false positives and false negatives in their results. So they have to be trained. Those end users have to be trained around the solution. They have to understand it. They have to love it. And if you haven't done that piece of it, the end users could be very, very frustrated and then not use the solution anymore. So make sure it's better than what you're already doing, and make sure you do some training for the end users on how the solution is to be used.
Fantastic. Thank you so much. We have another one. Based on your experience and opinion, what are the top mistakes businesses might make when it comes to data science?
I think the number one mistake that I see businesses make is, instead of taking one data science question, and really focusing on it, they try to take on too many business problems and solve them with data science. You burn your data scientists out that way. And you don't ever get very deep in your understanding of what's happening under the surface. And you never actually go back and improve your data either. So I would say start very, very narrow. Make sure that you're picking the business question that's really important, and do it and work on it, and let your data scientists wrestle with it for a longer period of time than you think might normally be typical for something like that. But let them really do good work. Data scientists are curious. They want to do amazing work. They're often given too many things to do and not enough time to do any of them. They can do amazing things for you with enough time.
That's great. Thank you so much, Kristie. There's a few questions, but I think it's time to move on before we go into the panel. So I'll make sure I share those with you, or the A2.AI team will, to make sure that we get some responses out. But I wanted to thank you so much for coming in and really enlighten us with all the automation that exists there within Domo. It's a fantastic platform, and I encourage everybody that is at this virtual conference to go check out Domo if you haven't already, because it can make your life much, much easier. So, Kristie, thank you so much for joining us. Thank you for your time.
Thanks, Tom. My pleasure.
Take care. Thank you.